Hello all, my name is Janil Popat. Let us begin shear strength of soil. Shear strength is very much important phenomena in soil mechanics. When the soil is loaded, the stresses in the soil gets induced. As these stresses gets up to its limit, the shear displacement takes place. Now what is shear strength? So, shear strength is nothing but the ability or property of resistance to continuous shear displacement of soil particles is known as shear strength of soil. Let us begin understanding shear strength of soil with a very simple but fundamental phenomena or mechanism of shear resistance. Now you can see in this figure there is a block lying on the soil surface. Now there are forces normal to the block. This is N for normal forces and this is tau, that is we can say tangential force, right? So a body is under normal as well as tangential pressure or stresses. So the element is under two type of forces, parallel and perpendicular. In other form, if we can see two bodies are in contact with each other like this, one body and second body under normal as well as tangential forces. Same way, if we want to analyze it like a friction problem, we can solve this like as normal and tangential are having an angle phi. The phi is angle or coefficient of angle of friction. Now, let us see it numerically to understand shear strength. Now, tau max, when it will reach to tau max, when the body will move, it will reach up to maximum stress. After that, the body will start moving. So, tau max can be written as mu into n, where mu is coefficient of friction and n is the force normal to it. Now, from the friction, mu is taken as 10 into phi, where phi is what? Phi is coefficient of angle of friction. Tau max can also be written as n into 10 phi. So, this is very basic simple mechanism of shear resistance of any body, XYZ, any body. To understand shear strength, let us move to more technicalities. Shear strength is basically derived from three basic items. One, cohesion or adhesion. Second one, frictional resistance, and third one is resistance due to interlocking. Now, what is cohesion? What is adhesion? So, we have already discussed cohesion is the bond or the attraction force between the same particles of the same material, when adhesion is the attraction force but on which the different type of materials or different type of material particles, that is cohesion or adhesion. So shear strength is derived from these attraction force. Same way frictional resistance, when your body, when any XYZ body is resisting the movement, it will create frictional resistance, and that is how it will govern shear strength. And third one is resistance due to interlocking of particles. What is interlocking now? Now, whenever, whichever the type of soil is there, but there are some bonds in between soil particles. These bonds are getting interlocked when it is under some type of force, and that will give you shear strength. So, basic three ingredients for shear strength are these. Now, let us understand basic terms as internal friction and angle of internal friction. So, first of all, internal friction, the frictional resistance between the soil particles which is directly proportional to the normal stress is known as internal friction. When the angle, whichever it is representing the internal friction, that is angle of internal friction. Now, angle of internal friction is dependent or it is variable with different things like shape of particles. If your particles are having different shapes, the angle of internal friction will change according to that. Same way, if roughness of surface is not uniform, the angle of internal friction will again change. Same way, denseness of the soil. If your soil is very less dense or very highly dense, it will have variation of angle of internal friction. So it depends on these factors. Now, let us understand Mohr's circle of stress. According to Mohr, in any strained material, in any strained body, there must be three mutually perpendicular axes which are under only and only direct stresses and no shearing stresses are there. So these three axes are known as principal axis and planes going through that are known as principal planes. Now, most major stress from all these three stresses is known as major principal stress and minimum of them is known as minor principal stress, and the remaining one is known as intermediate principal stress, and as we have talked, all the corresponding planes are known as major, intermediate and minor principal planes. Now, let us understand with a figure. Now, this is Mohr's circle. A Mohr circle is nothing but a graphical representation of a locus of point sigma and tau. So, you can see a graph between tau and sigma. In this, there is a circle which is known as Mohr's circle. Let us understand elements of it one by one. In this Mohr's circle, the lines which are lying horizontal, we can say O to B. O to B is showing major principal stress, where this vertical line is showing minor principal stress, or we can say OB is showing major principal stress as well as OA. We can say OA is showing minor principal stress value. Now, in here nomenclature, you can also see that sigma-3 is known as minor principal stress, and whatever the maximum of all three stresses will be there is known as major principal stress and is written as sigma-1. Sigma-1 plus sigma-3 by 2 is shown as the center, distance to the center of the Mohr circle. Here, this gap is taken as sigma-1 minus sigma-3 by 2. So, from any graphical presentation, you can derive the value of sigma-1, sigma-3 and as well as resultant stress. Now, here OD which is having angle beta is making a resultant stress of them. Same way, you can see OE and DE as OE is showing normal stress and DE is showing shear stress on the soil. So this is a graphical representation. Let us understand it more thoroughly from this explanation. For an example, let us take a soil sample like this, in this shape. If it is under some pressure sigma-1 from vertical, or we can say normal, and from horizontal it is zero pressure. So shearing is zero and only direct forces or direct pressure is applied. So we can see here principal plane being generated. So in two diagram figure, we can see one point here. Let us talk about that point, that pole point, principal stresses and minor and major principal stresses. Here you can see the same figure. Here I have not written zero shearing forces, zero shearing pressure. but only I have shown direct, right? So sigma 1 is only there. Now, if we can cut the section and see this point, it will be having sigma 1 direct stress and tau shear stress as 0. So there is only sigma 1. So this plane must be a principal plane. Now, let us see it on tau versus sigma plot. Here, if I talk about these, here, if a locus of that point will be tau 0 and sigma something x, y, z some amount, right? Let us assume some point on the graph like I have shown here. So, this point is showing stress on these point right now. Moving forward, if I apply stress from these direction and I see principal stress is there, remember that I can only take principal plane and principal stress as and when there is only direct stresses. No shearing stresses should be there. So now the point will be having some data sigma and some tau. There will be like these point. After that, these point will be there. After that, now gradually you can see the graph is moving as I am changing the plane. Now if I stop it here, I will have sigma 1 or direct stress as 0, but shearing stress is also 0 here. So I am getting origin as the point of the graph. Now moving more further, I will have point like this here. Tau and sigma both will be in negative. If previous direction was positive, they will be going in a negative direction according to graph only. Moving further, I will get like points like this. And coming back again, I will have a circle, a complete circle. Here, sigma 3 has been written and which is showing you a minor stress. But at this point, tau should be 0. So, at this point again, sigma 1 will be there which is major principal stress. Now, it is very simple. The Mohr circle you can see it on the slide. Now, you can see a question popping up in the screen. Very basic question. Now, what is the stress at this point? If you are asked that what will be the stress at this origin pole point, there is a single answer to that, that is the circle. Stresses will be this circle, and this circle is known as Mohr's circle of stress. And Mohr also states that if the soil sample is lying like that and sigma 1 and sigma 3 are acting on that, the values of sigma, tau and sigma r can be stated as sigma is equal to sigma 1 plus sigma 3 by 2 plus sigma 1 minus sigma 3 by 2 into cos 2 alpha. Tau is equal to sigma 1 minus sigma 3 by 2 into sin 2 alpha, and resultant stress sigma r is equal to under root sigma square plus tau square. So Mohr derived all these formulas and they are very much fundamental to that, so we have to remember these formulas. So that's it for this lecture. Thank you.